13 years ago, I learned Grasshopper. And when I learned Grasshopper, I used a few exercises to understand the capabilities and the main logic of how it works. In this video, I'll walk you through exactly the same exercises that I learned while I started my Grasshopper journey, and there will be a bonus at the end. So without any further ado, let's start. Before I start talking about Grasshopper, I want to walk you through the exact logic it has within Rhino. So in Rhino, I'm assuming that you have kind of an experience in Rhino. Therefore, I'm not going to go into details within Rhino. But within Grasshopper, or to understand Grasshopper, let's take a closer look at the logic of the parametric model and static model first. So if I draw these curves, copy them, and kind of have them here. Let's say you're an architect, product designer, interior designer. You have a profile curve that you want to kind of extrude, right? You take this curve, you type extrude curve, you extrude it up, and you have your surface. And at the end of the day, you may want to change this, you may want to have some kind of perforation in it, openings in it, or change the shape, scale it, so on and so forth. However, if you think this is a piece of your process, then you may see that whenever you need to go back and change this macro form or bigger shape, then you need to go back and fix everything. So to avoid that, there's one single thing that we can use within Rhino, which I call baby steps to the parametric modeling, which is called record history. So if I come in here, select record history, click on it, make it activated so that it turns bold, I do the same thing. Extrude curve, and I extrude it here. But when I extrude this curve now, what I start to see, since I activated the record history, I can move this curve, control point of the curve, sorry, but I can move this, literally move this curve too. I move it up, I move it down, I scale it, I rotate it, and so on and so forth. So by doing this, I am able to change the shape. However, if I want to have an opening in it, let's say if I want to have a sphere that is kind of, that will be taken out from this piece. So let's say I want to split this. I want to split from this, and it says the split command broke history on one object. This means from this point on, all the things that were recorded won't be able to remember it from Rhino. So when I say OK, then I put all these, or change all these control points, nothing changes, right? So if I remove this, we go back to what we have. However, there's another limitation within this, and it is you take this and move or disconnect the end geometry or the form geometry from the initial starting geometry, you again break history or object. But that's kind of the limitation where we have with Rhino or record history. So it basically works great with singular or kind of baby steps again, singular commands in Rhino. But when you want to add more to it, it's going to be not working. Therefore, we can use Grasshopper for those things. And it takes us to the very first example or exercise that taught me Grasshopper. So if I type Grasshopper to my, oops, I think my video is lost for a second. So let me go back to this, fix my video. If I can refresh this. hold on, give me a sec here. Okay, I'm back. I'm sorry for the inconvenience, but I accidentally hit my webcam. So I can go and type Grasshopper to the command tab, command prompt, or I can click on this. So when I click on Grasshopper, let's start with the basics. So what I see here is all the pieces that I have here is in rectangle. So the green rectangles are meaning that there are some Grasshopper scripts, Grasshopper files that I used before that can be opened by my computer. So whenever I hit, like let's say this one, I can open this one because my computer knows where exactly this file is. That's why it is green. However, when I click on red, which is not possible, and it says missing. Okay, so I don't or I cannot open this. Anyways, this is the starting screen, and I can click on new document here. So my very first thing that I'll be using is putting bifocals. Bifocals will enable you to see all the names of the components that I'll be using during this demonstration. So if I click this, you see the name of the component is gone. Now you know exactly what I'm using as the component. So let me go through the basics of the Grasshopper canvas first. By the way, this is called Grasshopper canvas. Within this canvas, we do have file, edit, view, display, solution, and help. Pancake, Crumble, Alpaca, Orthograph, Alphron, Cyclops, and Shapediver are the plugins that I'm using. I'm not going to use any of them here today, so you don't need to worry about those. File is the place where you open the file, save the file. Sometimes you install plugins through special folders, component folders, or you create user objects, and so on and so forth. Edit is where you have copy, paste, group things, cluster things, redo, undo. View is how you view things in the Grasshopper canvas, and display how you display Grasshopper components, how you display geometries in Grasshopper, and so on and so forth. Solution is where you recompute, like basically refreshing your solution, and where you want to change the visibility settings of the components that you have, so on and so forth. Help is the helping menu, tutorial files, Grasshopper files, Grasshopper support, so on and so forth. And beneath those we have, starting from params, it goes to Kangoo to these tabs. And again, these are my plugins. If you don't have them, that's all good. You can start looking into the params where we have the components that are kind of empty containers, especially here in the geometry tab. You can imagine these components as empty containers where you can put some geometry in, okay, or you can use kind of the existing geometry that you have and link it to somewhere else. Primitive is basically you can have numbers, booleans, colors, inputs where we have sliders, panels. Like there are a lot of things that are going on here, but unfortunately openness and openness 2 are again my plugins that you don't need for today. Math is where you have mathematical operations. Sets, this is where you have lists, sets, sequence, trees, so on and so forth. I'll explain this in a later video. Vector is where you can create vectors, planes, points. Curve menu, where you can analyze curves, divide curves, basically create curves, create splines, and utilize them, such as offset, split, trim, and so on and so forth. Surface, basically the same, analyzing a surface, creating a freeform surface, creating primitive surfaces, subby, and util surface, such as cap them, join them, and create surfaces from points, so on and so forth. Mesh is the same. Intersect is the mathematical, consists of mathematical intersections, physical intersections, regions, and shapes like surfaces, curves, solids, and so on and so forth. Transformer, we have scale, move, rotate, all those kind of things. display where we change display settings, how we see things in Rhino from Grasshopper. And Rhino 8 or Rhino is a set of components where you can use native Rhino commands or features. Kangaroo is another, it's kind of another subject for another tutorial series, I would say. It's a physics simulator that is embedded now in Rhino, in Grasshopper, sorry, I guess starting from Rhino 7. So, if you were to do the same thing here, if you want to extrude this, by the way, this will be the first exercise. If we are to extrude this curve, how we approach that problem within Grasshopper. So whatever you want to do, whatever you want to get from Rhino to Grasshopper, you use the empty containers. That's why I go to prompts under geometry, I go to curve and grab a curve component which is now empty. And when you right click to it, you will see a bunch of different options, and within these options you can say select one curve. This will take you to the Rhino screen and ask you curve or edge to reference. I can select this one, and I can say, now you may realize that the curve is turned into an empty curve component is orange, and when you add something to it, it turns into gray. Okay, it means you have something inside of this container. And when you have this orange color, you see floating parameter curve failed to collect data. By the way, when you click on this balloon, you see the exact problem that you are facing within this component. So I can delete this for now. And the other thing that we do, obviously there are a lot of ways to approach this problem in Grasshopper, but since I know what I want to do, I can go to the surface tab and look for the extrude component. And you see there are a few extrude components. You can always hover over to the component and see what is needed by you. So I can go to extrude, grab the extrude component, connect it here, or before I connect this, maybe I can go through a little bit more with you. So every time when you have a component in Grasshopper, you will have left hand side and right hand side, meaning inputs and the outputs. So in this case, it is asking you to provide a base, profile surface or base geometry like a curve, and direction, which is a vector, which I'll talk about in a little bit more, with a little bit more detail soon. So I press the left button of my mouse and I see this arrow and I connect this arrow to the base. Okay. The second thing it asks is the extrusion direction. Let's say we want to do the same thing with these guys, but I want you to pay attention one thing here in Rhino. So when we say extrude, we extrude curve, right? However, we have a lot of different options here, right? Like the output, direction, both sides, solid yes and no. I mean, in this case, it's not possible since this is an open curve. Delete input to a boundary set, kind of base point or direction. You can change the direction to something else, right? For instance, you may want to say, I want to have a diagonal that goes here to here, and this will be, oops, I want to change my, yeah, see the diagonal change or the direction is changed. You can come back and then say, okay, this is my new direction. So I'll be doing it in Z direction. The same is very valid for Grasshopper. So you need to provide as many details as possible for you to control the outcome. Okay? Therefore, I go to the vector tab, I grab a vector unit Z. And when I connect unit Z, I start to see this turns into gray, but I don't see any surface. Actually, if I zoom in enough, I started to see the surface is formed. However, the factor for unit Z is 1 or set one as default. That's why we don't see it from a distance, okay? So what I need to do, I need to go to the input, grab a number slider, and connect this to here. And I connect this to here. Now it's even worse because now it's 0.250. So if I right click to this, click on edit, I can see a new menu within the slider. So I can change the name. I can change the name to curve extruder. I can add an expression if you want to, such as x multiplied by 2, which will take every number that you provide and multiply it by 2. Don't need that. Grip style, you can change it to shape, box, text, whatever. Slide accuracy is an important one if you want to have floating point numbers, integers, even numbers, odd numbers. So let's keep it in floating numbers, but let's have maximum 1000 and minimum minus 500, which you can do. And within this setup, you see that the range is now 1500, which takes the minimum point of your slider and maximum point of your slider. And you can slide this to wherever you want. You can double click to this and then say, this guy is going to be 550. You can click OK, and now we start to see this. There is a tiny shortcut to this. I know you don't want to do this all the time, right? You don't want to go into input, click the number slider, and right click edit, so on and so forth. Instead, what you can do, you can double click, you can say minus 500 with one digit is smaller than 1000, one digit, and when you press enter, you see the same slider happen, okay, without the name. So I can say curve extruder to this one and use it along. So what I see now, whenever I put a curve inside of this, it will take that curve and extrude it. This takes us to one important topic about Grasshopper. So in Grasshopper, whatever you're creating is basically previewed in Rhino. That's why you're not able to select it, delete it, and do a few different things that you want to do in Rhino. Therefore, we can start talking about how we preview things in Rhino from Grasshopper. So if I come over here, I will see some preview settings. Those settings are telling you or giving you options how you can preview them or you don't preview them. For instance, if I click this, do not draw any preview geometry. It's not going to draw any geometry. If I click on this, it will create the geometry only in wireframe. If I click on this, it will draw the geometry in a shaded view. This is something really interesting. So if I'm guessing it's coming from AutoCAD, you can create an area where you want to preview things. So you see, I don't see this curve, even though I select, I see only this surface. Yet, if I take this surface out of from this area or window, I won't be able to see it. When I drag it back, I started to see it. That goes along with draw preview geometry. So if I have the window and if I want to draw geometries as wireframe, I see them as wireframe. Click on this, I can turn that off, turn this on, and so on and so forth. When you click escape from your keyboard, you exit from that menu, basically. So the second thing that we have in this menu is the only draw geometry for selected objects, meaning you can only select the objects, preview the objects once they are selected from the Grasshopper canvas. I select this, I can preview them, and if nothing is selected, it won't be previewing anything from Rhino. And we can unclick to this. Document preview settings. This is a little important and depends on your computer. So if I zoom in, you see the curve and surface has some kind of misalignments. I can come over here. I can say disable meshing. You see turns into a wireframe again, and I can come back here, low quality, I can make this document quality, which aligns my curve and the surface perfectly. It depends on, again, the power of your computer and graphic card. It's up to you. I'll just go with the low quality here, okay? The other thing that we have here is the document preview settings, this guy. So whatever you see in Grasshopper is basically default, will be previewed as red, and when you select them, they will be previewed as green. Yet you can change them. If you click on document preview settings, you have this menu here, and it says normal. You can say normal will be pink, and selected will be blue. And obviously you can change this, you can make all these adjustments, okay? And when I say okay to this, now I see all the components that are not selected but visible in pink. When I select them, they are kind of bluish, okay? So this is how you extrude a curve. Yet I want to talk about a little bit more on this slightly or relatively simple Grasshopper script. So for instance, if you want to send this to someone, or if you want to send this to a friend that will work on the thing that you created, what's going to happen is you send this file, and let's say they don't have the Rhino file, so I delete this. So what they will see is exactly the same thing because they don't have the corresponding Rhino file, right? Therefore, when they open the script, they won't be able to see anything. So if I copy this here, and what I started to see, I want to demonstrate this a little further, but when I create a panel and connect this panel to it, you started to see referenced planar curve. This means the curve that you put in to this container is coming from Rhino, which means it's linked to the Rhino file. To embed this curve to your Grasshopper script, you right click to it and then say internalize data. When you say this, you now have planar curve. You can delete this, but you still have the results, okay? However, let's say you add this circle, you add this rectangle, and you add this ellipse to the equation, okay? When you get the script and you want to add these tiny things, right? Because you're working on it and you want to test a few different ideas, you right click to it, manage curve collection, and you can select add item. You can add this item, you can add this item, you can add this item, and you can add this item. You click OK, now you have them in, but they are referenced. So you may want to say, okay, I want to kind of internalize these, and now even if you delete them, you'll be able to see all these outputs. Okay? And if your friends want to keep them, he or she can right click and then say bake, just like we are going to do. So if your friend says bake to a default layer, or let's say layer 5, he or she will get the curves already. You can say the same thing with the surfaces. We can come over to the bake and we can go to layer 5, but we can say, okay, I want to change the color of my baked geometries. Unless you bake the geometries, they are not real, they're just preview in Rhino. So you can change the color of your baked geometries. However, I highly recommend you to follow the layers settings that you already have. Decorations, arrow start and end, never use that. You can change the display mode of your baked geometries. You can say, okay, I want to bake them in the shaded menu. However, I want to display them as wireframe. You can select that. You can lock them or hide them. You can basically group them. You can define some keys and values to your objects as well. So when I say okay to this, you started to see I have basically a group of surfaces, okay? And one last thing here, you may see that some of the surfaces that I have has two faces, like orange face and a white face or the black face, depending on the layer. It's a setting that I'm using in Rhino, which makes my life a lot easier, especially dealing with complex surfaces. You may see object settings and color back faces. So if you just turn this off, you see everything in the same color, which kind of creates confusions in terms of what is the backside and front side of the surface. So if we create color backface, we now know, okay, actually my cylinder is upside down, so I can click on this, ungroup this, and then say flip. And now I have it the way that I want to. The same goes for the box. I can easily see this. This is really useful and helpful if you're dealing with surfaces. So I go back to here, turn this off, turn this on, turn this off, and now I can go back to here and I started to see again my surfaces, despite they are not defined here or visible here. And let me save this as my first exercise, curve extruder. And by the way, if you want to get a copy of this script, go join my school community. This will be posted there as a video, YouTube video. You can see if you watch this in YouTube, this is great. You can go to the link in the description, join my community, and get this working file. So this is the first example or exercise that taught me Grasshopper. So let's go to the next one. So in the next one, I'll be taking you to a kind of a different mindset, because in this one, what we did is we had only one single variable. One slider changes things, but what happens if we connect a geometric variable to this system? So you probably heard the term attractor points. Now let's take a look at how we can create our attractor perforation within Grasshopper. We'll go and take a look at it from different point of views. We'll start with a size example. And to give us a clear idea, what I can do, I can grab an image gallery. I use image gallery a lot. It basically enables you to put an image from your computer so that it will be linked to your Grasshopper script. Instead, you go in and check your image from your picture viewer or some other source. So what I'll do, I'll go to here, I'll go to here and I click OK. I started to get my exercise video. So I'll get this guy here, okay? So then what I see here is a set of points, and within these points, what we see is a set of circles, like a grid circle grid, however you call it. And based on the distance between my orange point to the black circle, blue circles, it's really early in the morning, blue circles, we see size changes. And let's see how we can do that. To demonstrate this, I go to vector, I go to the grid tab, I grab a square grid. Whenever I place this, I started to see two things. I see the grid, but I see a smaller grid inside. The reason for that is you basically have a plane defined to this plane input, and it was XY. And now you see this is actually my XY plane, and this is my plane. So if I turn this on, sometimes you get some Grasshopper files that's previewing the plane huge or really tiny. So if you want to change that, you go to display, preview plane size. In my case, it's now 10, but if I make it 100, you see this is my plane now. If I go and say 1, this is my plane. Now Regardless, I'll right click to it and preview that off. So the next thing that I want to do here is basically change the sizes. So let's say the size is going to be 500. This means each edge of my squares is going to be 500. So each line that you see here is 500. And extend x and extend y is meaning basically how many pieces you want to have in x, how many pieces you want to have in y. Okay, so this is our first grid system. However, we have the grids here as circles. In my case, they are now squares. How I can convert this into square grid, surface grid, circle grid, is there are a few things you can do. We can take a piece of, like we can basically have a point in the middle of each square that I create and put a circle on top of that. So I go to the curve tab or surface tab, get the area component, which will give me the centroid of each area. Okay, and based on this, I started to see some X like crosses, right? The crosses are indicating the centers. You can also go to display and change the point flavor. You may want to have it as dots, you may want to have it as points, or you may want to have them as crosses, which is the common thing. One other thing that we see here is the cells are connected to geometry with a dashed line, which means we have different set of lists, different channel of information. In this case, these columns are in different lists, and different lists are connected to geometry with dashed lines. So if I right click to this, I can flatten this, but I'll be talking about that later with another video in a lot more detail. So for now, we can just say, take all these squares and use them as one single surface instead of having them column by column. Okay? So the next thing that I want to do, I want to go to the curve tab. I want to go to the primitive and grab the circle component. When I put this, I don't see anything except I see the same goes, or the same thing that we saw with the extrusion. So the radius is too tiny, therefore we don't see anything from a distance, right? So what I can do here instead, I can say, okay, if I put 120, I started to see there are some circles. I can increase these, decrease this, and when I increase this, I started to see this cool kind of great patterns that are emerging from the intersections. However, that is not the case for our grid system, circle grid system. But what I see here, this is still dependent on me finding the right slider or right amount in the slider. However, I can convert this into a little bit more a parametric grid. So if I take this, or if we draw a circle around this guy, okay, and if on this circle, if I can find the right area or right distance as my radius, that radius can control my tangency situation with each circle. In other words, if I can find the right number for this radius, then the circles that I'll be creating will be touching on one point to the next one if they have neighbors. So instead of connecting a number here, what I can do, I can go to the map tab, I can go to the operators, I can get a division component, I can basically divide this into two, and when I do this, I connect this to here, now I started to see that I have a circle grid. And whenever I change this, it's basically following the same rule. I can add new circles on X or Y direction. Okay, so that's basically the first step. The second step is basically putting the attractor point. So let's start with 1 point only now. And what we see here, those points are previewed differently, like in a different color. But that's what we can do. I can go and create a point component, right click to it, and set 1 point. And when I do this, I can go to display and to the preview dot display, connect this as a dot, preview this off, have a color swatch. Maybe that color swatch is going to be white, and for this size I can go in and say 100. This may be a little big, but not that much, so we can still keep it. I can change this to a bluish color, and what I can say is I can right click to this and say group. I can double click, grab a scribble, put the scribble, and say attractor point. Okay, and I can right click, first select this, right click, and add this to the group as well. So the next thing that I want to do, I want to understand the distances between this point, my attractor point, and my kind of areas or centroids, right? To be able to understand the distance factor, which will be used as my sizing factor. So what I can do here is I can grab this down, and I can go to the vector tab, and in the point I can grab a closest point component. I use closest point. Obviously you can use distance, it will do the same thing, but this is very handy when it comes to multiple points that you want to have the relationship. So distance component works great with singular comparisons, whereas this one is working a lot better with multiple comparisons, and we have distance output from this guy as well. So I can connect this as my cloud, and I can connect this as my point. Okay, and now I started to see distances, and when I connect this distance, I started to see huge circles, and those circles are basically changing the size of like my initial circles. However, this system works. When I move my point, it kind of changes, but there's no control. One slight or one sloppy fix that I can use here, I can go to operators, go to division, and divide this distance into 150 and put this in. When I put them in, it's a little too much. I'm going to decrease this a little. Okay, what I started to see this. You see, if my point is close to the grid, what I started to see is my circles are getting really tiny, and the further they go, my circles become larger. I can put them in, I can place them here. However, when I move them too much, you see I started to get, again, some kind of overlaps or intersections which I don't want, which I don't have here. So to avoid that, I'll just stick to this one, and I'll be using this distances as a scaling factor rather than having them and using them as the radius alone. How do I do that? So for that, I go to the transform tab first, and I go to Find, and then I grab a scale component. So what I'll be doing, I'll be scaling my circles, and when I put this in, I started to see something happen. That is because we have the circles, we have the center for scaling. Now basically each circle that I create is being scaled based on this point, and I have the factor with 0.5, so each circle is being scaled down to the half size, okay? So to avoid that, I can grab another area component and place that as my center, preview this off, and the factor I can put here is now a 0.5, and when I select this, I see them as 0.5, right? But if I use this distance to drive my factor, scaling factor, what I need to do, I can go to math and grab, sorry, not the mesh map, and remap numbers. What remap numbers does, it basically will take these distances. So for instance, if I grab a panel here, I'm seeing a lot of different distances, right? 5,000, 3,000, 4,000, 5,000. I saw somewhere like 3,000, 2,000, maybe 1,000. You see they're ranging differently. What if I say, take the maximum and use it as 1, and take the minimum and use it as 0.1? That's why I need to use remap. So it basically takes a set of numbers, and based on their starting point and end point, in this case I need to extract the minimum and maximum point of these numbers. What bounds does this? You create or you connect bounds to understand the minimum and the maximum points of this distance. So if I connect another panel, amongst these numbers we have distance between, or minimum distance of 234 till 6,135. So what I want to do is I want to take this as, use this as 0.1 and use this as 1. So this will be the source input, because it's basically asking me this source domain. In this case my source domain is this, and I can turn this off, and what I can do as the target, I can go to the math constructor domain, and this domain will give me a change to 0.1 to 1.0, and when I connect this, I started to have the fact, like when I preview this, oh, hold on, give me a sec, I have to put my camera back on. Activated, okay, here we go. So now we are back. Sometimes I hit my webcam, I'm sorry for that. So whenever I move this really far away, you see nobody's touching nobody, okay? Like it's only touching here with 1 point. And if I add more points to this equation, like let's say this guy, and this guy, if I say set multiple points, I have this happening. And the good thing about this, that my system now is working with all these points. So whenever you add a point, see this difference. And the good thing about this is, when I add another point, like let's say here and here, I can say, okay, what I can say here is manage point collection at this guy, and then this guy too. And when I increase the number on the x, whatever you're adding is basically being added with this equation that we are having right now. So that's how we do this. That's how we create an attractor point in Grasshopper. Again, this is my second exercise, so I can save this, but there is a slight, there's a slight variation of this. I can say attractor point size and save this. So this is basically changing the size, right? And we can put this in the other way around. So I can make surfaces or circles larger when they are close to the attractor points. It's kind of up to you when you change the domains input. When you change them, alternate them, you see this happens. So this is great. Now we kind of use a variable where we change the size of the circles. This can be a data visualization, this can be something, but we can do the same thing with another purpose. So why don't we do this? Why don't I copy this and paste it? And I copy this and paste it here. And maybe I can group this. Right click to it, change the name of the group, pull out a scribble and say attractor size. Oops. And make it larger and add to this group. Now what we are going to do, we can do the same thing, maybe with some kind of colors, we can have some colors along the way. And to do that, what I can do here is I can copy this and put them maybe 35,000. Okay, and now maybe I can put a point here, 2.0, and move this 35,000. I just want to make sure the same things are aligned here. I can put this point in, set one point to this guy, connect it here. Now we started to see this because all the things that I'm in this grid is being impacted by these attractors. So I should come over here, right click to this, and set multiple points. Now here we go, we have the exact same thing. But now the goal, let's take this, let's take this out, and maybe let's take them all out and just go with a rectangle in this case, or the square in this case. So what I want to do, it's instead of having this, I can grab these curves again and using them as my guide to be kind of connected with different, or to be visualizing the distances with colors. So I can say, okay, if you are close to my attractor point, let's be red. If you are far away from my attractor, let's be some other color. To do so, first thing that I need to do, I need to go and convert this into a surface. We can do this, or we can go to the surface tab. As long as your curves are planar, when you put the surface component, they will take those curves, planar curves, into surfaces. But you can go to freeform and then you can say boundary surface, which will do the same exact thing. However, for some reason, the boundary surface takes more time because I'm assuming it's approaching this with a lot more detail. So it took, you see, 9.4 seconds, but this took like 76 milliseconds. So we don't need to use this. We can go ahead and use this one. And to be able to change the way that we see them, I need to go to the display tab. Under preview, I need to create a custom preview. So when I connect this, I see everything in pink, which is my color now. But if I make this, a little red, maybe bluish, I start to see the blue, but I'll be using a gradient. So if the goal is to be able to use changing colors, I need to provide a component that has a range of colors instead of a singular color. So I go to params, input, I'll grab a gradient. So what this gradient does, it basically has a lot of colors in it, which are controlled by the lower limit. Lower limit means pink, upper limit means the red in this case, and parameter means the parameter that you are changing the colors, right? So in this case, we don't really need this. Okay, I'll be showing you another trick that helped a lot. That will be super helpful. And that trick is we want to get the distances, right? The minimum distance will pink, maximum distance in red will be red in this case. So I go to the map and I'll go to, again for the bounds, I grab the bounds, but I need them as numbers. Now they are kind of given me as a domain, which is different. So I go to domain, deconstruct domain, connect this. Now I get those as my numbers, like start and end. So I connect this as a start, connect this as my end, and I connect the distance component as my parameter. Okay, so if I click to this, now as you see, I change this to my kind of color-coded visualization. All right. So if you right-click to this, you can see a lot of different presets for this. So you can say, okay, start with blue and then go with red. Or you can say start with blue and go to purple. Or you can say start with like these kind of white to black. Or I don't know, like colorful stuff. Or you can go to something quite simple as we had, like maybe we can grab another gradient and then you connect, you delete this all, you connect this here, you connect this here, and you connect this here, and you connect this guy here. And what we can say here is basically you can double click to this and you can say color left is pink, we can have this yellow, color right can be that yellow too, okay? And you may want to have another point, which is random right now, but it's kind of a blue. You may want to have another one, which is kind of green, and you can change their locations. You can basically take them to 35, this and that, and then I say okay to this. I started to get this. And the preset, again, like if you say, okay, I'm really not happy with this one, so you can come over here and then say, okay, I want to have a bigger yellow here. Put this in. Now we have a bigger yellow. But again, if you right click to it, you can say, okay, I want to have this kind of thing. You can have it. You can remove by dragging them out. You can remove these points by dragging them out of your canvas. So you may have two colors. You can say okay to this. But again, it's really up to you and what you want to show, how you want to present your work. Okay. And then what you can do, you can right click to this and say bake. And let's say layer 3. If we turn this off, we'll start it to, yeah, we are starting to see them and shaded like this. If I preview this off so we don't see anything because we are in wireframe, we go to shaded, and if we go to rendered, we have all these colors here in your Rhino screen as well. So it used to be different workflow to get these colors, but now with Rhino 8, you right click to the preview geometry and you bake them, and you bake them, you get the colors in the rendered view. Okay, I can preview this off and look at this. And what I can say now is basically I can group these guys also, copy this, and attractor color. I can add this guy to here as well. So this is the second exercise that I learned when I was learning Grasshopper, and it took me for a while to be able to, you know, operate smoothly in Grasshopper. And this is the second exercise that I learned that taught me Grasshopper, the logic of it. In the first one, we learned how to use the colors, and we learned how to use the sizes. And in the second one, we use how to use colors within this system. And if you want to get this file, join my school community for free. You'll get this link, you'll get this working files for free. All you need to do is follow the link in the description, which will take you here, and join my community. So I already said this, but just say this again. The last thing that I'll be showing you as the bonus exercise is a train silencer. So if I go and create a new document, maybe I preview everything off. Okay, and maybe I take all these guys and put them into layer 1 just to be a little more organized. So what I'll be doing is a bonus exercise now. It's called train silencer. So basically what we are going to have first a curve, like let's say as the railway. Okay, so this will be my curve. And within this curve, set one curve, within this curve, this is our railway path. We'll create the railway, and then we'll have silencers that are opening and closing up as train goes. So it's a good exercise to understand another variable type. Now we have geometric variable. Now we have, at the beginning we have singular variable, which is the slider. In the second one we have kind of geometric variable, which is the motion that we can control. And in this one, the geometric variable will be controlled inside of this geometry, okay, as a train silencer. So what I'll be using is, I'll be creating the path. So I'll go and offset this curve, okay? I'll offset this. Oh, it's not planned. Oh, you see, while I was drawing this, it goes all over the place. Therefore, it's not being able to offset. And this is great because whenever you have a failure problem, 99% of the time in Grasshopper, the component goes into red. So when it's red, it means it's not performing well. And what I can do is I can just, I'll either project this or set point, I'm assuming. Yeah. If I say this, probably I'll start to get this, but I kind of don't like this curve that much. So, and you see it's now turned into a normal workflow, or the problem is solved. But what I would want to do is basically delete this and have something a little bit like this. So I'm assuming this is planar. Okay, so put this here. And now this is going to be defining my rail. So I can zoom into this guy just to be a little more safe, or a little safer. So I can say 2000 for this. Okay, that's too much. We'll make it maybe 350. That's a little too much. 150. And now I have the rail distance, but I want to also have the same thing. Okay, I want to have the same thing with the other direction, meaning the negative version of it. So I can say, okay, I want to have the curve, or I want to have the offset again, or in short, what I can do, I can copy this and paste it here. I can have this guy here, I can have this guy here, or I can copy this and paste, put it here, copy this and paste, put it here. This is kind of the way that I really would like to work, because now there's no overlaps. And I have the same input for the similar outputs, except the fact that I need to put negative here. Negative basically takes your slider and multiplies it with -1. When we have this, here what we see. So what we are seeing now is the tested. So where I'll be putting the train silencers is basically a side. So I'll be having some lines. If my train is here, they will be perpendicular. If my train is here, they will be like parallel or lateral on the ground. Just to make things a little more safe, I want to put this guy here, okay? Because I want to change this based on the same value, all right? Then now the next thing is to define the number of silencers that I'll be having. I'll be doing the same thing once and then copying and pasting it for the other one. So what I'll be doing, I'll be dividing this into smaller pieces by dividing them into frames. If I grab the perpendicular frames, or if I just put frames, perpendicular frames, not the frame, but frames. So what I'll do is I'll basically get the curve. This is my curve. I'll get a count, like let's say 25. I'll get 25 frames. However, I see them really small because I made them really tiny, if you remember. So if I make them 10, I started to see them. If I make them 100, I started to see them a little better. So the goal is to be able to have some kind of lines that are aligned with the perpendicularness of this curve. So I go to the vector tab, and in the plane, I will deconstruct this plane. And when I deconstruct this plane, I get a point, origin point, and I get a y-axis. The y-axis that can be used to get the line direction. So maybe a small demonstration for that is I can grab an STL line, and this will be my starting point. And for the direction, I'll be using y. But if we want to take a look at the display, vector display, because we are basically creating a line on a particular direction, so this can be my direction and this can be my vector. You see, now my vector is showing down, okay, which is kind of a problem because I want to use this on this direction. So you may want to see if I use this as my direction. You see, I started to get lines that I'm seeing them as they go down. Maybe I put 50 just to be safe. You see, my lines are going down. The reason for that could be the direction of my curve. So if I flip this, it may take this and solve this, but it didn't. So that's all good. What we can do instead, we can change this direction, or we can change the like the length. We can put a negative length, which takes us to going up, okay? Which is something that I need because if we don't get this straight, maybe I can preview this off. So if we don't get this straight, we won't be able to rotate them as they go along, right? As they go along. So remember, if my train is here, so what I want to do is I want to make this as perpendicular so that we don't hear the noise as it goes. So this can be my first set of lines. And the next thing that I want to do is I basically want to rotate these, right? So I want to rotate them I want to rotate these lines, and the plane that I want to rotate them will be the same plane, curve frames or planes. So what I can do, I can grab a plane input and connect it. I can plane input and connect it to here. For the angle, I just want to show you something really small. So you see the angle is now defined as 0.5 multiplied by pi, which is 90 degrees. We can get a radians component, connect this to radians, and if we say 45 degrees, we start to see that all of them are rotating in 45 degrees. You see? Or 0, or kind of 90. Okay? But the thing that I'm really not happy with, now these lines are turning towards the railway. Remember, this was the railway. So what I need to do is just need to put this as a negative value here. Right? Now we know that they're rotating outer. The goal is not to control the angle by a static number. The goal is to control the number with my curve. Okay, if I create another one of this, and if I say point on curve is a component where you would see, where is that one? Okay, so I just need to go to the curve tab analysis, point on curve. So what this does, it's basically give you a point on the curve based on its length. So it starts with 0 and you can put it to the very end. You see, this is kind of representing, this will be representing our train. So what I'll be doing, I'll just take this guy over here, however, copy this and paste it, just to get a clear kind of lines instead of overlapping things. Okay? And I'll be using this distance with all the origins so that those distances can drive my rotations. So if I pull them down, if I grab the closest point, if I get my origin, if I get my cloud here, and basically what I do is get the closest point and distances. I'll be doing the same remap trick that I used and go to domain, remap numbers, distance, bound, and this time I'll be using a target between 0 to 90 and connect it over here, and I'll be using, oops, my cat is in the, okay, my cat is in the frame right now, so my webcam is off, but I'm assuming it's on now. Okay, sorry. So what we are going to do is to basically take all these numbers. I can preview this off and connect it over here. And now what I started to see is the lines that I'm having is basically going here, and oh, by the way, I need to use negative, sorry. And when I do this, when my train is here, I see that these are kind of perpendicular, and when it goes off, they are lateral. And when I move this point up, I start. Nohut ya. Oof. My cat again. He kills the webcam. Give me a second. Okay. So, as I was telling now, it's perpendicular because the train is over there. And if I take them and loft them all, you see, I get it here. And the other thing that I can do is basically, okay, so the next thing that I'll be doing the same thing for the other direction, right? So what I can do here is basically take them all down and copy this and paste this for this rail, the other side of the rail, and what I see is it's basically doing the same exact thing. However, in this one, we want to keep things not negative. We want to keep things on the other direction, right? So we should be deleting this guy, okay? And that's basically what we do. Obviously, we can use a little bit more kind of like order here. I can group this guy. I can group this guy. We can group this guy and this guy too. These are the angles, we can group them too. But in short, what we do is basically take this train and move it here, and as train goes, our rails are kind of being protected by this lamellas so that people won't hear that much of noise. So this was the bonus exercise, so let me save this. I'll be saving my Rhino file as well. And again, to get this file, go to the link in the description and join my school community. You'll get all these files for free with the latest post that I'll put today. And if you are serious about learning Grasshopper, I have 5 spots open to work one-on-one. You can go to the calendar link in description and book a discovery call with me just to see if you want to learn Grasshopper, how you want to learn Grasshopper, and how serious you are learning with Grasshopper. And you can see if I can be helpful or not. Until next one, I hope this helps. I'll see you in the next one.